All right, ladies and gentlemen, so we've just finished up our work with polynomials in terms of multiplying them through and adding and subtracting them. And now we're going to take that and we're going to be working in reverse. We're actually going to be taking and dividing, and this is called factoring. So we're going to take, when we had two binomials times two binomials, or a monomial times a binomial, or whatever, and you multiplied them through and you got a bigger expression. Now we're going to be taking that expression and going backwards. And again, it's called factoring. So factoring is dividing a polynomial into its factors, right? So for example, if I have the number 12, right, I can factor it into 2 times 6. I could factor it into 3 times 4. I could even factor it into 1 times 12. That's called factoring. And we can do the same thing with polynomial expressions. If I had just a very simple, if I had x to the third, I can factor that into x times x times x. I could do x squared times x, right? So that's what we're going to be working on, is kind of working backwards. We're also going to work on something called factoring by grouping, which is used for polynomials with 4 or more terms, and there's more information about that right here. And again, we'll go over how to do that. We're eventually going to be solving equations that involve factoring, and in order to do that, we have to know what the zero product property says, which if the product of two factors is 0, one of the factors must be 0. All right, so today what we're going to work on is factoring by grouping and factoring by finding the greatest common factor, which is a skill you did way back when in 6th grade, okay? So we're going to, it's called using the distributive property, but again, we're going backwards. And we're going to be looking for the GCF. All right, that's what we're going to look for. So when I start with this and I have 27y squared plus 18y, I want to break it up into 2 or more factors. What did I multiply together to get 27y squared plus 18y? So I'm going to take a look at the numbers first. I want to know what is the biggest number that can go into 27 and 18. All right, and hopefully you know that that is a 9. Right, 27, or 9 goes into 27, 9 goes into 18. Okay, then I'm going to worry about my variable parts. So I want to know what goes into both y squared and y. Well, when you're dealing with variables, you want the smallest exponent, which is a little backwards because you're thinking greatest common factor, but it's really the one with the smallest exponent. So y will go into both y squared and y. All right, so now what are we going to do with this? So what we're going to do is we take whatever our GCF is, and we're going to write that out front. Inside the parentheses, we're now going to do a division. I'm going to say, okay, well, what happens if I divide these? And we did division of monomials earlier, right? This is really what we're doing, is we're going to take each of these and we're going to divide it by 9y. So if you need to show this, if it helps you, if you can do it in one step, that's great. So I know 27 divided by 9 is 3. Y squared divided by y, we're subtracting our exponents, is just y. Oop, I forgot a y here, sorry. 18 divided by 9 is 2. Y divided by y is just 1. So I have now factored it, right? I have now taken 27y squared plus 18y and I have written it as the product of two factors, 9y times 3y plus 2. All right, that's what I've done. You can always double check it. Right? If I wanted to check this, I can go through and re-multiply through. 9 times 3 was 27. Y times y was y squared. 9 times 2 was 18, and then just y. So that's my check. You can always go back through and re-multiply it to see. Okay, so we're going to work on finding a greatest common factor, and then taking and dividing it out by that. So when I look over here, so I need a GCF, greatest common factor. So I'm going to look at the numbers first. So I have -4, -8, and 2. So the biggest thing that goes into those is a 2. Now I'm going to look at my variables. A squared, A, and A. So again, the smallest exponent there is an A. B, B squared, and B, smallest one is a B. So I am now going to take and divide each of these things by that. So again, if you want to show that, if it helps you, so I'm going to divide everything by 2AB. When I write it, because I have to show it as a factor, so the greatest common factor goes out front, and then whatever is left when you do this division goes on the inside. So -4 divided by 2 is -2. A squared divided by A is A. The B's cancel. Over here, -8 divided by 2 is -4. A's cancel. B squared divided by B is B. Over here, 2 divided by 2 is 1. A's cancel. B's cancel. So this is now factored. I'm writing it as the product of two factors. 2AB times -2A minus 4B plus 1. All right, so we found a greatest common factor, we divided everything by it, and we write it like this. If you can go from here to here and not have to show the division, that's great. All right, now, let's talk about factoring by grouping. So if I take a look here, and I'm trying to find a GCF, I have Rn, 5n, R, and 5. There is nothing that all four of those things have in common. So I can't pull out a greatest common factor. But what I can do is I can group them together. Because if you look at this group right here, Rn and 5n, those have something in common. They both have an n. If I look at this part, -R and -5, they both have something in common. It's a -1. All right, so let's see how this is going to work. So for right now, I'm only going to concern myself with Rn plus 5n, and I'm going to do just like I did up top. My GCF for this part, for the blue, they both have an n in common. All right, so my GCF is n. So if I put n on the outside, well, what's left? I'm going to divide by n. So Rn divided by n is R. 5n divided by n is 5. So that was just the blue part. I pulled an n out, my greatest common factor. I was left with R plus 5. All right, now I'm going to do the same thing for the green half. So I'm going to pull out a -1. So I'm going to divide everything in here by -1. Well, -1, -R divided by -1 is R. -5 divided by -1 is +5. Right, so again, I'm going to go back and show what I did up here. I divided all of those by a -1. I divided both of these by an n. Well, now what happens, if you notice, inside this parentheses is the same exact thing, R plus 5. So I can put this, the two coefficients, so to speak, out front, and write that as n minus 1 times R plus 5. So it looks a little different, but I can put those together, and then the R plus 5 stays in parentheses. And if you were to go through and multiply out, I'm going to show the check, just so that you can believe me. So I have to do my distributive property. N times R is Rn. N times 5 is 5n. -1 times R is -R. -1 times 5 is -5. Nothing I can put together, but it matches what I have up front. Okay, this is new stuff. We're going to spend a couple of days on this. So don't feel like, oh my God, I don't get it already. We're going to keep working on it. But let's take a look over here. So for B, I have, again, there's nothing in common that I can pull out of 4QR, 8R, 3Q, and 6. So I'm going to try grouping them. So I'm going to look at my green group, and I'm going to look at a blue group. Again, I'm just using colors because it helps me, and I'm hoping it might help you. So when I look at this green group, I know automatically I can pull a 4 out. And I can also pull an r out. So I'm going to divide everything in here by 4r. So I'm going to have 4r on the outside. On the inside, if I divide it, 4's cancel, r's cancel, I'm left with q. Here, 8 divided by 4 is 2, r divided by r, r's cancel. Same thing I'm going to do now for the blue group. My GCF for the blue group is going to be a 3. It's adding in front, so it's going to be a positive 3. So if I divide each of those things by 3, I'm going to get q plus 2. Oh, and again, what happens now? Well, this matches this, which means I can put the 4r plus 3 together. So 4r plus 3 is one factor, q plus 2 is the other factor. All right, let's try a couple more of those on the other side. So factor each polynomial, right? And this is still by grouping. All right. So when I look, there's nothing in common that they have. So I'm going to group them. Green group. What's my GCF of the green group? Well, fortunately I wrote over that. But they both have a C in common. So I can pull out a C. So when I factor that, C goes on the outside. What's left on the inside? C divided by C is 1. 2CD divided by C, the C's are going to cancel, and I'm left with 2D. All right, well, let's try over here, the blue group. So in my blue group, I have 8D minus 4. So again, this time I'm going to be able to pull out, I'm actually going to pull out a negative 4, and I will show you why in a minute, because I need to have these, what's inside these parentheses match. So if I pull out a negative 4, I'm going to be left with negative 2D plus 1. These match. Even though they're written backwards, negative 2D, positive 1, they match. So I can then put the C minus 4 together. And I don't care if you write it as 1 minus 2D or negative 2D plus 1, doesn't matter to me. And there are your factors. All right, letter B, 2mk minus 12m, 42 minus 7k. So this one, you know what? I'm going to just rewrite it now automatically and put the k in front so that it matches up here, because I can do that because my commutative property says I can add numbers in any order. So now I'm going to group them. Group, group. So I should have done them in different colors. Sorry about that. Let me re-erase this. 12m minus 7k plus 42. Sorry, I'm trying to keep the color scheme going here. So green group, red group. All right, so my green group, I can pull out a 2m. So my GCF for that one is a 2m. That means 2m goes out front. 2 divided by 2 is 1. M divided by m cancels. I'm left with k. Minus 12 divided by 2 is 6. M's cancel. In the next one, because I need these to match, so I'm going to have to pull out a negative 7. So negative 7 divided by 7 is k. 42 divided by 7 is negative 6. So once again, these match. I can put those two together. 2m minus 7 times k minus 6. Okay, we're going to save the solving part for another day because we need to go through and talk about that. Any questions? I know it's new. I know this was a long video. But again, we will be working on this for a couple of days. So questions, write them down next to your notes, bring them to class, and we will go over them. Have a good night.